So, good morning and welcome back to the new series of Slumberger Academy. Today we are starting to new web to talking about the logging, the production logging. So, when we are talking to the production logging, we are talking about several types of measurements for establish the health of wells, both in oil and gas. So this is a clear example of final results of this kind of measurement. We can use spinner flow meters, fluid density, fluid temperature, well pressure, water hold up, production and rate. So what does it mean? Production log consists, as just we say, in several measurements, which are used in complementary capacity to determine fluid and flow properties. Generally, we are make several types of this for establish the pressure, temperature, and also the fluid density and viscosity. Production logging is a critical technique used both in oil and gas and geothermal industries to evaluate and make the well performance, identify the production zone, detect the anomalies, and assist the fluid contribution along the well bore. So it's clear just a physical and fluid dynamics evaluation of well bore performance in different steps, different types of first in the pre-production, in production, and the long life of well bore. There is both application also in different type of fluids in oil and gas, steam, and water, and to establish also the temperature and the flow contribution. There is a specific application like determine the density of your wellbore fluid mixture, especially when we have different physical phase, like in geothermal case, regardless of your well's deviation. Accurately measurement flow rate in tubbing, casing, and open hole, and detect leaks with your compact. Quantifying fluid entity, gas leaks, injection zone, and cement stops via boreal fluid temperature analysis. So the production logs helps engineers to make diagnosis problems that can be occurred with the life of single wells, and they are also used for manage and surveillance of multiple wells or entity reservoir. This is a clear application also in change in phase in operation in mature oil fields. Is identified zone that can be make excessive production of water, especially in mature field. The hydrodynamic problem and physical challenge that can be occurred in well bore is this can be schematized in this image. There is in vertical well bore there will be a near vertical well with dispersion oil or other particle in fluid, oil and water mixed across the section and the pipes, and so there is no good production and captation. Deviation well, in some deviation well we can have a high complex flow structure and water phase and bottom of the pipe. We can have dispersed oil in phase and uppermost well on the pipe. So this is a typical challenge that can be in some well bore. In near horizontal well we can have a stratified flow structure, oil at the top, water at the bottom, and mixture of the down of 2 in the middle pipe. So this is the free case can describe the physical and hydrodynamic problem that can be incurred in application on and in challenge of production logging. So core, which will be the core object of production logging. Clear identified zone of contribution, both for oil and gas wellbore and geothermal wellbore. Fluid types identification. We can identify oil and gas water, also in classical reservoir, but we can identify also steam, water and gases in geothermal reservoir. Flow profile, there is a good application in flow profile also. Flow profile means the dispersion of water in horizontal and vertical in classic reservoir like oil and gas, but also in geothermal. Close flow detection, challenging of beam casing flow, and well integrity also in oil and gas and geothermal. Lay in action efficiency, we are critical in geothermal reservoir, and we can evaluate with the logging production in oil and gas, but is too critical in geothermal evaluate the reenaction with production logging. So generally we have this distinction, this different situation between the oil and gas wells and geothermal wells, because in oil and gas wells we have multiple phase in the same time, oil, water and gas, horizontal, and we can have the horizontal and deviated well, so we can have these hydrodynamic problems. And objective often includes zonal shutoff, water coning, and gas breakout. So geothermal wells is too different because we can have fluids. Generally, we have two-phased, limited to two-phase stream water, and high dissolved gas like CO2 or sulfurous gas. Reenaction well are critical to, is very important to make the surveillance of pressure. Emphasis on heat extraction efficiency and zonal production and thermal breakout is essential for geothermal reservoir and wells. So in this case we have some example of tool using in production logging and application. We generally use it, for example, the spinner flow meter to measure the fluid velocity and reliable in multi-phase flow. The temperature log is used to detect inflow-outflow zone, sensitive to minor flow change. Pressure log, so the pressure log is essential to measure downhole pressure gradients. And the caliper log is essential to measure the borehole diameters to establish the hydrodynamic problems and make hydrodynamic simulation. The noise log or acoustic log is essential to detect the turbulent flow or leaks, especially in geothermal wells. The radioactive tracer is track injected tracer movements. And instead of this, we have also the resistivity or captivity log that generally is not so frequently, but we can also classify as production log to identify phase. If you have only the two phase, especially if you have only water and oil, is can be a good technique to identify the two phase. Different phase in oil and water, or can be used also resistivity log. But the essential is spinner flow meters, temperature log, pressure log, caliper logs for determine the hydrodynamic problems, and also noise log like that. So we have also an example of interpretation of production logging, and for example, for profile, we can show the fluid velocity and in different type of zone. The production index of PE is for reservoir deliverability, zonal contribution from each perforated or open zone, cross flow, zone where fluids are moving between layers, wellbore phase behavior, gas separation, steam quality and geothermal, pressure downtown, that can help in diagnosis of reservoir. So I show you an example that is an example of using spinner flow meters to determine the spinner flow meters to determine the flow profile and the fluid velocity in a single or multiple reservoir zone along the wellbore. So this is the table that is linked to this kind of measure. You make the instruments of spinner flow meters. With spinner flow meters we can determine the flow velocity in different zone, and the contribution of fluid in different zone. So we have this is a grid sample, because we have, for example, the flow velocity in the first zone that is between this depth about 100 to 101, and we have a second example. This is from 101 and 105, and the second velocity is this, because we have a minus contribution but with DAIG in the first part. So we can also establish with the relation of spinner flow by velocity and the diameters the flow density. So we can observe that in this case the flow intensity is the same in also the free zone of contribution. So thanks for attention. In the next appointment we are focused about to the different types of tools using in this case, for example, the zone contribution, what we mean zone contribution, fluid type of detection, cross flow, with best practice and work example. So we analyze also the caliper logs for measure and establish hydrodynamic problems, and we are focused about two more specific themes.